Hey everyone, it's me, Miss B, and in this video we are looking at the Unit 1, Lesson 21 Cumulative Practice Problems. So let's dive right in. The triangles here are each obtained by applying rigid motions to triangle 1. So triangle 1 is down here. I'm just going to make that extra visible for me. Which triangles are translations of triangle 1? So translations are going to be anything that is in the same general orientation, meaning it has the point towards the top and the base at the bottom. So not triangle 2, but 3 and 5 and 7, and all of these ones here will actually work. And if you notice, all of these are odd numbers. So we're going to say the odd number triangles because they are all facing the same direction. The odd numbered equals we'll say they're all facing the same direction, but you know what I mean. There's probably a more mathematical way to say that, but that's a good enough explanation as any. We would also say maybe they have the same orientation. They're just, got their point upwards and the base downwards. Okay, for part B, it's asking which triangles are not translations, and the answer is the even numbered triangles, so the ones we didn't select. The even. And we can basically say because they're facing a different direction, but we can say they have a, we can say a vertex instead of a point. Point doesn't make sense. They have a vertex facing downward instead of a flat base. And that's the answer for that one. So the even numbered triangles, vertex facing downward instead of a flat base. Okay. So for question 2, we have this quadrilateral is a parallelogram, and they're asking us to find the measures of angles 1, 2, and 3 and show or explain how we got them. So one of the things I am going to use here is the idea we kind of talked about a little bit in class today with straight lines across the bottom. So I have to move mine into position in order to make it extending. But we are basically going to make some extending lines here and extend each of these sides because we have some relationships we know about sides and angles that we're going to be able to use to make this work. So pardon me while I adjust my lines here just a little bit, and then we'll get started. So if you draw or basically extend each of these lines, we can then talk about them as maybe corresponding angles or vertical angles or things like that. There are a bunch of things I know I can write on this. Given that 80 degrees, I know I have 80 degrees here. Since it is a parallelogram, we basically know that we have opposite sides being parallel from each other. So if we know that these are parallel, so that's our top line and bottom line, and then we also know the side ones are parallel to each other, we can say a lot of things with vertical angles and corresponding angles and all sorts of things. So this 80 degrees is also going to go in the top corner here as 80 degrees because that's a corresponding angle. It is also going to correspond with this angle over next to 1, 2, and 3, so many different places. But that basically is going to allow it to travel all around this shape. It's also going to correspond or one of its corresponding angles would be vertical with or correspond with angle 2. So all of my points here, or all my angles here, are now labeled 80 degrees, but that did only apply to one of my angles, so we can say measure of angle 2. When we're actually giving them values, we do want to put the m in front for measure, so measure of angle 2 is 80 degrees. Now, we want to find 1 and 3, but the great news is we know everything should add up to 180, so the other angles here should all be 100. And for the same reasons, they are going to be corresponding or vertical angles, or maybe even alternate interior angles with all of these other positions. So they asked me for angle 2. They're also asking us for angles 1 and 3, and angles 1 and 3 are both going to be 100 degrees. So I'll say measure of angle 1 is 100 degrees, and measure of angle 3 is 100 degrees. Now, just so I actually have something written down I showed you how I got them, but I'm going to write out an explanation here of how I got those, just so that if my teacher was reading this, they know how I got it. So that would be using vertical angles and corresponding angles. Also, if you just drew the extended lines, that would be a good way of showing me how you got those things. But we basically use vertical angles and corresponding angles. You don't really need to use alternate interior ones, but vertical angles and corresponding angles because a parallelogram has two sets of parallel sides. That's why I'm allowed to use the corresponding angles. Vertical angles will be true no matter what, but the corresponding ones actually are going to need the parallel things. Okay, that is it for question 2. Well, let's keep going for question 3. So this one says, in the figure shown, lines F and G are parallel, so that's great. We want to select the angle congruent to angle 1. So angle 1 is right here. We want to know what is congruent to that. Well, I know that 4 is vertical from it, so 4 is equal to it. 1 also corresponds with 5 because it is in the same general location. And then 5 is vertical from 8. So all of my green angles here are answers, and that means that my answer is angle 8. So I'm just going to select that one with a highlighter. Now, what is the angle relationship? These are 1 and 8 are actually alternate exterior angles. And that comes from alternate being on opposite sides of the transversal right here, and then exterior because they are both outside the sandwich of these parallel lines. So that may not be something we've defined yet, but that is if we're applying words that we know. We know alternate means on opposite sides of our transversal. And then interior meant that they were inside, like 4 and 5. So exterior means they would just both be outside, like 1 and 8. Okay. For question 4, we're looking at some congruent stuff, and we're going to name pairs of congruent angles and explain how we know. So BDE, that's the marked angle, is congruent to BAC. That's given to us. So we want to name another pair of congruent angles and explain how we know. Well, if corresponding angles are congruent, that means the lines have to be parallel. And if those lines are parallel, let me move my parallel markers here. I'll make them a little thicker also. So it's basically telling us these are parallel. And because these are parallel, we have a couple different options for what we can say are equal, but I'm going to say the other two parts of my triangle here. So I'm going to say BED and BCA. So I'm going to say angle BDE. And then this is the notation form of it. It's the little curly line above an equal sign. That is a symbol that means congruent. BDE is congruent to BCA because the original pair of corresponding angles, because the original pair of corresponding angles makes the lines parallel, or means original pair of corresponding angles being congruent makes line L parallel to line M. And then we can say BDE and BCA are corresponding. So we're saying the original corresponding angles makes the lines parallel, and then now because those are parallel, this new set of corresponding angles have to be congruent. Okay, let's go on to question 5. This says describe a transformation that could be used to show corresponding angles are congruent. And then part B is to describe a transformation using to show alternate interior angles are congruent. So a transformation that would show corresponding angles is to translate, because these are going to be in pretty much the same general position, we can translate them along the transversal and show that they map onto the other one. So translate the angle onto the corresponding angle. So you may have things like labeled with A and B and C and D and all of that. We don't actually really need to include any of the letters here. We're just going to translate it. And that would be by a directed line segment from vertex to vertex of these two angles. Now, a rotation is the next one, actually. So the transformation showing alternate interior angles. I would use a rotation, but I'm going to be a little bit more specific. Instead of just saying rotate it onto it, we're going to say rotate the angle 180 degrees around the midpoints of the two vertices. So to show you what I mean when I do that, you don't have to include this picture, but I'm going to include a picture for you. It's just not necessary for your answer. This transversal, if I'm saying that this, we'll use a thinner marker, we're saying that these alternate interior angles are equal. We want to use the midpoint right in here and rotate 180 degrees around that, and that'll map them onto each other. And that's really it. So I just wanted to include a visual so you know what I'm talking about when I write out that description. So that means, I believe we're on to question 6. Yep, we're on to question 6. Lines AD and EC meet at point B. So which of these must be true? So this is our basic formation of vertical angles. We are gonna basically analyze some rotations and things here and see what works. So first they said 180 degrees clockwise rotation using center B takes D to A. Well, B, good that we're using the center. Does it take D all the way over to A? Well, yes, because that makes a 180 degree angle between the image, the pre-image, and through there. So I would say that could be correct. A 180 degree rotation using center B. Although, oh, actually, I'm sorry. It's not necessarily going to take it to A. I'm like, it's going to take it. I was like, I know there's a reason why this is not correct. So it's technically not correct because we can't guarantee that A and D are both an equal distance from B. D, what we do know is that D is going to end up on this ray, but it looks like it might be closer. Like this looks a little shorter and this looks a little longer. So it's not that one, but it is this one here, right below it. The image of D after 180 degree rotation using center B lies on ray BA, and this is just literally because we don't know the exact distance. So even though the logic seems correct for A, that kind of got me at first too, not quite correct of an answer. Okay, the third option, so option C, if a 180 degree rotation using center B takes C to E, then it also takes E to C. So if it takes these 2 points to each other, or if it takes one to the other, then it should take the other to the original. That is true. And that's because if it takes one onto the other exactly, that should mean that B is the midpoint of those two, which means that not only would they lie on the same ray, but they would actually land exactly on top of each other. They either would both have to do that or neither of them. Okay, and then we have ABC congruent to DBE. So that's ABC and DBE. I agree. Those are vertical angles. Now, the next one is to say that ABE is congruent to ABC. And that's not true because this is ABE right here. And that is not congruent to ABC, which is this angle. So, not true for that one. Okay. Points E, B, and C are collinear. So question 7, this comes back from lesson 19, but we're going to explain why A, B, and D are collinear. So this is something we haven't quite talked about specifically in my class, but this is going to include some rotations and rays. So if they're telling us that E, B, and C are all on the same line, collinear means on the same line. So on the same line. I'm going to zoom in here and I'm going to write this a little smaller. Collinear on the same line. Now, we actually need to say that 3 points are collinear. Any 2 points, you can draw a line through them, so any 2 points will be on the same line. but a third point being on that line is important to note and like say why it has to be. So now we want to explain why A, B, and D are collinear. So if we rotate around center B, right here, we already know EBC, this is a line. So we want to rotate. We could rotate this whole thing, but if we rotate this line 30 degrees, basically, if we rotate this line 30 degrees, it will land on this line. We're going to rotate it around point B. So I'm just going to write this out, but this will be sort of a formal explanation. We're going to rotate line EC. So line EC, we're going to rotate that. And now because we're not doing 180, we have to give a direction and a center. So we're going to say direction, center, and amount. So you can generally give those in any order. So we can say 30 degrees clockwise around point B. Now, because we know the points are collinear, that is going to take, based on this construction here, that's going to take ray BE, and that is going to take it onto ray BA. BE is taken or mapped onto, taken to, this is a ray, is taken to ray BA. That's the results. And then we also have that ray BC is taken to ray BD. So essentially what we have is that this lands here and this lands here. And since EBC is collinear and they land on those opposite sort of rays, we can now say, oh, well, that means that those rays have to be, they have to be lines. So rotations basically take lines to other lines. So A, B, and D must be on a line together. Poor handwriting there, together. Okay. We're going to skip over question 8. And the last one we're looking at here is question 9. So, question 9, we have triangle ABC congruent to triangle A prime, B prime, C prime. We are going to describe a sequence of rigid motions. So we want ones that take A to A prime, B to B prime, and C to C prime. The first thing I like to do, though, is check direction. So A, B, C, it looks like this one is going counterclockwise. But if I look at A prime, B prime, C prime, this one is going clockwise. So that means I am going to need to incorporate a reflection here. So I can say this one was counterclockwise and this one was clockwise. So I am going to start with a translation and then we'll do a reflection. So because these are separated and they don't share a point, we're going to translate first, and then yeah. I think we'll also need to rotate a little bit specifically because it doesn't show us any degree measurements. So I'm going to throw a rotation in there just to make sure that we have things lined up. So I am going to say translate ABC so that we can say so that A coincides with A prime. And then, now that we have A matching up, we're either going to choose B or C to rotate until they match. Now that will make one of our lines actually work and match, and then we are going to reflect across that line. So the goal here is that essentially I end up with something like this, and I can reflect across like my center line here in the middle. So pardon my not very great drawing, but I am probably going to rotate so that B connects with B prime, because that was the piece that I had actually drawn in here, was I connected it through B prime. So that sounds like a plan to me. I am now going to rotate the image until B coincides with B prime. The last step is then to say reflect the rotated image across line, and we're using A prime, B prime. So translate so that it coincides with A. I can actually, I'm going to actually show the images here. So give me just a moment. Also, I'm sorry if it's a little noisy in the background. I try to use some like noise cancellation stuff, but I'm never always sure exactly how that turns out. So I try my best. Okay, this we translate until it ends up here. Great. Now, I want this shape again. I'm going to copy it, paste another version of it, and this is what we're going to rotate until it lines up like so. But I can't rotate around a center, so I have to actually try to do it by hand until it lines up. There we go. Although this one would be generally like red, so I'm going to trace over it with red. Or maybe just, nope, that was too big. There we go. I'm going to erase the center of it there, and I can maybe trace this one over in red. Aha, we can. So that is the rotated one. And then we're going to reflect across the line A prime, B prime. That is this line right here. I'm going to have to scooch it a little. Here we go. So we're going to reflect it across that. So hopefully those make sense. The first blue one is my translation. And question 9 is the end of this assignment. So that is actually it for everything. Let me go back, so in case you needed this one, you can always pause it. But yeah, that was Unit 1, Lesson 21, the cumulative practice problems for illustrative math geometry.